Okay, good evening. This is Mr. Casey from Pendrahowell School in Swansea. Also with me is Mrs. Claire Dixon. She's the other side of the room, and she's going to be doing the second half of the session. So this is our live revision session for Carl and Cymru of the Intermediate Maths Autumn sessions. And I'll just give you a quick run through of what we're going to try and achieve this evening. Okay, so the first session, which we recorded and is available on the website, was solving linear equations, and the second was simultaneous equations, which I did both those sessions. And then the next two sessions, Mrs. Dixon did on percentages. So the first part of this session, the live session we're recording now, is going to be covering sort of the main points of session 1 and 2, and then the second part, when Mrs. Dixon comes in, is going to be covering the main points of sessions 3 and 4. Okay, so here we've got the scheme of work. If you've watched the live recordings, this is on the live recording. But what we're looking at for the skills that we're going to be covering is linear equations are regularly come up in both maths and numeracy papers. So the content on the left-hand side is numeracy, and the right-hand side is maths only. So the linear equations, they are really common questions which come up in both. When we look at simultaneous equations, they don't come up in the numeracy papers. They only come up in the mathematics papers. Okay, so let's just discuss the differences, because I've covered both in my previous videos, but I think it's worth a quick recap to discover the differences of the two. So the equation you've got there is a linear equation, so it only has one unknown. So you can see x there. We're not going to solve this equation at the moment. We'll just discuss. X is what we're looking for. We're trying to find out the value of x, but there's only one x there. There's not another letter. There's not a y, for example. So that's a linear equation. And then the one you can see there on the right-hand side has got an x and a y, which would be very difficult to solve. In fact, impossible to solve unless we just give it a bit of a guess. But what we would have is another equation to work out with in conjunction with it, and they're simultaneous equations. So there's two unknowns. There's the x and the y we're trying to find, and we're going to find them simultaneously. So that means you solve both equations at the same time and find the value of both unknowns. So when we discussed equations, I'll run through this really quickly because I discussed this in my video. It's all about balance, and it's all about whatever we do to one side, do to the other. So have a quick look at my diagram. So I got an x on one side and 2 blocks, and on the other side I've got 6 blocks. Now if I were to get x on its own, what I would have to do is take away the 2 blocks that have just disappeared, but of course by doing that it would make the right hand side heavier. Now that's not ideal. Obviously we always want balance, so what I would then do is take 2 blocks off the right hand side and then restore the balance, meaning x is equal to 4. So it's all about balance, so whatever we do one side we do to the other. So we're first going to look at some linear equations. It might be worth you pausing the video at this stage, just have a very quick look at quick go of these yourself. That's of course if you're watching the video back after it's recorded. Obviously if you're watching the live version you're not able to do that, but quickly pause the video and have a go, and then I'll jump back in and we'll run through the answers. Okay, so hopefully you've had a chance to have a go at these. So with this first one, again, I mentioned balance earlier, so it's a -8 there. So what I'm going to do is I'm going to add on 8 to the left-hand side. Whatever I do to the left, I must do to the right. So I'm actually adding on 8 both sides of the equation. So I'm only left with 7y this side, and 34 add 8 gives me a value of 42. And I divide both sides by 7, and that gives me a value of y equal to 6. And that's all as our aim. Even with the simultaneous equations we'll do later, we're going to letter equal a number. Okay, this equation, I'm going to expand the brackets first. So 15h plus 21, of course, the 3 outside the brackets, I've multiplied individually by the terms inside, and that's equal to -24. Be careful with the negative, it does often catch people out. I'm now going to take away 21 from both sides, and I'm left with 15h on the left-hand side, but now I've got -24 take away 21, which is -45. So when I divide at the end by 15 both sides, that gives me a value of h equal to -3. And then the last one on this slide, all of this top bit is divided by 6. So if I multiply by 6, that will get rid of that divide by 6. But I do that both sides, so I'm left. And you know what I'm going to cheat a little bit here. I think I'll expand the top at the same time. So I'm going to do 3 times e, which is 3e, and 3 times minus 4, which is minus 12. And at the same time, I'm multiplying this 2 by the 6, and I'm getting 12 on that side. So I've kind of done 2 steps in one there because I'm conscious of time. I expanded the top, I've multiplied both sides by 6. What I now need to do is add on 12 both sides just to get rid of that minus 12. So I'm left with 3e is equal to 12 add 12, which is 24. And when I divide by 3 at the end, 24 divided by 3 gives me a value of e equal to 8. Okay, so they're probably some of the more basic equations you're going to get. Quite often what we do face is equations with unknowns both sides. So if you just have a quick look at this slide, again, if you're watching this video back, you're able to pause it and have a try those questions. And I'll come back in a second. And then after that, we're going to move on to simultaneous equations. Okay, so let's take a quick look. So this one, there's 8a's over the left-hand side and 3 on the right. So I'm going to take away 3a from both sides. Remember, we can take away letters from both sides as well as taking away numbers from both sides. And that leaves us with 5a equal to 15. Divide both sides by 5, and that leaves us with a value of a being equal to 3. Okay, this one, I could probably do this, a bit quicker than I normally would. So instead of adding 2 both sides, what I may do is add 2 to both sides. But at the same time, what I'm also going to do is take away 3d both sides. Now, if you're quite new to equations, I probably wouldn't suggest you do this in one step, but of course I'm doing this to save a bit of time. So that gives me 4d on the right, because I've added 2 and got rid of that minus 2. I've taken away 3d from the right-hand side. So actually, this 2 here, I'm adding 2 to it, and I've got 4. So 4 times something is 4. Of course, that must be divided by 4 both sides. That must give us a value of 1. This one, underneath this brackets, my best advice would be to expand them. 3 times 3q is 9q. 3 times minus 1 is minus 3. And then the other side remains unchanged. And then if I take a look, I'm going to try and do the similar thing to the last question. I'm going to get all my q's on this side. So I'm going to add on 3 to both sides of the equation, add 3. But at the same time, I'm going to take away 8q. So I know this is a little bit messy. I'm going to take away 8q both sides. And then straight away, 9q take away 8q gives me just q. This 8q is gone, that minus 3 is gone. And I'm left with minus 18 add 3. And the answer is minus 15. Now, as before, we discussed this on my last session. Any answer you get, you can substitute back in. So let's say, for example, I substitute in d equals 1 in this middle question. I swapped d for 1 in each case. Then as long as it balances both sides, then the equation is right. Okay, so let's do a couple of simultaneous equations. And again, if you're watching this, if you're watching the recording, you can certainly pause the video and have a try yourself on a bit of paper, and then I'll come back in. Okay, so with this one, we're always looking at the coefficients either of m or in n in this case. We often use x and y for these, but they can use any letter in the exam. And in some questions, you're going to have to sort of make up your own letters for the question. So what we're going to do with this question, because the coefficients of m are the same, we're going to try and eliminate the m terms. So all of this becomes a big takeaway. And the reason it's a takeaway is because the signs are the same. Now, you may say that's a minus 6 and that's a plus 2. The signs are different, okay? But we're actually looking at the signs in front of the terms we're getting rid of. So that's a plus 4m and a plus 4m. So that's why we take away. Now, as it happens, this bigger number 26 is on the bottom. So there's no reason why I can't just take away in reverse, if you like. So I'm going to do the top. I'm going to take the top away from the bottom. So 26 take away 2 is 24. And then 2n minus 6n. You've got to be careful here. You subtract in the negative, so that actually becomes 8n. And I divide both sides by 8. The value of n is 3. Now, that's all hard work done because you know one of the answers now. So what we're going to do is we're going to substitute in the value of n equal to 3. And I can pick any equation I want, the top one, the bottom one. I normally avoid the negatives because there's more chance of making a mistake. So I'm going to write 4m, and I'm not going to write 2n, I'm just going to write 2 times 3, because I know the value of n, and that is equal to 26. I know 2 times 3 is 6, of course, so I'm just going to probably, at this stage, I'll take away 6 from both sides, take away 6, take away 6. So that leaves me with 4m equal to 20. And then when I divide by 4, the value of m is 5. Okay. Last example we're going to look at before we sort of do some exam questions is when you've got different coefficients. So in this question, we've got 3c and a 5c, so that's not really helpful. And we've got a 5d and a 5. Oh, there's a slight mistake in the question. I've just noticed a mistake in the question. So I could change that really quickly, okay? And I won't tell anybody if you don't. So what we're going to do is we're going to change that to a D. Now, the way it was, just to sort of explain why I have changed that, that's a C, that's a C, that's a D, and that's a B. You won't be able to work that out, okay? There's 3 unknowns in the question, so I think that was my fat fingers when I was typing the question. I've obviously just hit I've hit a B instead of a D. So now that that's changed, I think we can get on with the question. So this top one we're going to multiply by 2. Now the reason we're going to do that is because I want the coefficients of D to be the same. Okay, so I'm going to times that by 2, and remember you have to times every single part by 2. So that becomes 6c plus 10d. Remember, d is the letter we're going with, and 7 times 2 gives us 14. Try and give yourself a little bit more space than I've done. And then this one here, I really haven't got much space here at the side of the screen, but that's going to be all times 5. And hopefully we'll see in a second why I've chosen those numbers. So that's going to be 25c minus 10d equals whatever minus 9 times 5 is, which of course is minus 45. Now, the coefficients of d are now the same. One's a plus, one's a minus, but that's okay. It's the numbers we're interested in, and we've got 10d and 10d. Of course, the signs are different. Now, because the signs are different, we're going to add. We're going to add these two equations together. So 6c at 25c is 31c. If I do 10d, add minus 10d, that becomes 0. So these are eliminated. And if I do 14 plus minus 45, is actually the same as 14 take away 45, which comes out as minus 31. Now, I'm quite comfortable with that answer because I've got 31 on both sides. If I divide by 31 both sides, that gives me a value of minus 1 for C. Now, last step. As I said, I think the hard work is done now. All we need to do is sub in the value of C at minus 1. So what I'm going to do is I'm going to maybe use the top equation. So 3 times minus 1 is kind of what I'm doing instead of doing 3 times C. I'm adding on 5D, and that is equal to 7. Now 3 times minus 1 is minus 3. So I'm going to add on 3 to both sides. Add 3 there, and that gives me 5d equal to 10, and then I'm going to divide by 5 both sides, so d is equal to 2. Remember, d is equal to 2, not b is equal to 2. We'll ignore that b from the question earlier on. Okay, so let's have a look at a GCSE question. Again, it might be worth you pausing the video if you're able to, if you're watching it back. Have a quick go at that yourself. There is a lot of information. This would be a typical sort of question you'd find in an intermediate numeracy paper, but have a pause of that question, and then I'll come back in afterwards and run through the solution. Okay, so Iona and David went shopping. Now they bought some bottles of the same blackcurrant cordial and the same soda water. So Iona bought 2 bottles of blackcurrant cordial and 3 bottles of soda water. David bought 4 bottles of blackcurrant cordial and 1 bottle of soda water. And then tells you how much they both spent. Iona spent £2.04, David £2.48. So use an algebraic method to calculate the cost of a bottle of blackcurrant cordial and the cost of a bottle of soda water. Now, it doesn't give us any variables in the question. It doesn't tell us to use X or Y. But in this question, I think it's going to be worthwhile sort of making up our own variables. So the logical thing would be B for blackcurrant, and I think we'll use an S for soda water. So let's have a look at Iona first. So 2 bottles of blackcurrant, so 2B plus 3 bottles of soda water, 3C, and she spent £2.04. I missed the pound side out, but I do need to write the numbers with decimal. And then we've got David, I'll just put Dav for now. And that is 4 bottles of blackcurrant, so 4B, and also bought 1 bottle of soda water. I could put that as S, but I'll write 1S just so we know what's going on. And David spent £2.48. Now, looking at the numbers, I've got a 2B and a 4B there, so I could just multiply all of this equation by 2, and that'll give me a 4B in both lines, and I think that's what I'll do. Okay, so if I times that by 2, only the top one I'm going to multiply. I've now got 4B plus 6S, and then £2.04 times 2 is going to give you a value of £4.08, kind of the workings. Now, I'm going to kind of ignore this top line now, and I'm going to take these two bottom lines, and I'm going to take them away from each other. Okay, now, because the bigger values on the bottom, I'm going to do the top being taken away from the bottom. So 4B, take away 4B, they're gone. 6S, take away 1S is 5S. And then £4.08, take away £2.48. That's going to be 160 or 1.6. When I divide by 5, be careful here, it's going to be 32 pence. So obviously if you did it on a calculator, it'd be 0.32, but I'm just going to write 32 pence. Okay, so that is the price of 1 bottle of soda water. And then as before I did with the other questions, I'm going to sub in S equals 32, but in fact it's going to be 0.32, so I'm just going to put a 0 point in front of that. So I'm going to sub it into this equation, maybe the middle one as you're looking at the screen. So 4B plus 1 times 0.32, so I'm just going to leave that as 0.32, equal to 2.48. I'm going to take away 0.32 from both sides, so do that both sides. That gives me a value of 4B equal to 2.16. When I divide by 4 at the end, so I've got £2.16 if you like, divide by 4, that's going to be 54 pence. So the two values we've got are 32 pence and 54 pence, and that answers the question to find the cost of each. Now, we will look at the second GCSE question, but we are really short of time, so I'm not going to run through it. So I'm just going to talk you through the process. And the reason I'm going to do that really quickly is because you will come across this type of question from time to time. Now, they are angles in parallel lines. Okay, so what I'm going to do, just for the purpose of the video, is I'm going to form one of the equations. Okay, you can form the other yourself, and I think you'll have the knowledge then to work through them, and then I'm going to give you the answers. Okay. Now, because these angles, 125 degree and 2x plus 3, so they're corresponding angles. Okay, your teacher may have called them F angles to your teaching it. So we know 2x plus 3y is equal to 125. Now that'll be your first simultaneous equation, and then you find a similar equation with these alternate angles, okay, or Z angles your teacher may have taught you, and then you solve the simultaneous equations. So I'd suggest you do is certainly have a go at that in your own time. Okay, I'll tell you the answers. I'll put the answers at the bottom of the screen. Y is 15 and X is 40. Okay, so I haven't done the complete solution. Okay, but hopefully you'll appreciate, and I think I have got time. I'll write the other equation out as well. 3x minus 4y is equal to 60, and hopefully you can work through that process and you get the same answers as me when you do so. Okay, so we're more or less out of time. We'll have a quick look at this plenary. So the question is to solve the equations. 5a plus 7b is 63, and 10a minus 4b equals 18. And have a quick look if you can spot any obvious mistakes. Okay, so let's take a look then. So first of all, they haven't multiplied the 63. Okay, so when they've multiplied the equations, this first one, they've attempted to multiply by 2. So they tried to do that times 2 to get that. They've done a good job with the first couple of bits, 5a and 7b. That's okay. But they haven't multiplied the right-hand number. Okay, so the answer, if you like. So that's definitely a mistake. And then there's been an issue there with the taking away. Okay, so when you take away, you'd have had 14b there, and what they should have done, of course, is 14b minus 4b, which is 18b. So this value here should have been 18b. Okay, now the good news is when you get your exams, you have what we call follow-through marks. Okay, so certainly with this question, they would have picked up marks on the way, even for early mistakes within the question. Okay, so just be aware, if you think you made a mistake at the first stage, don't lose all hope and give up. Carry on with the question, and there's still an option to pick up marks along the way, because they follow through your method, and if your method is correct, there's still marks to be had. Okay, so thank you for listening for my first part of the session. We're now going to do a quick changeover of the headset, and Mrs. Dixon is going to come in and she's going to cover the next part. Okay, thank you very much.
Hi, good evening, Mrs. Dixon here. So I'm going to talk you through the percentages part. This will be roughly 20 minutes, just like Mr. Casey's part as well. Okay, so during the recordings that we've done previously, I did a percentages session on non-calculator work and then percentages on calculator. So I'm going to hopefully run through both of those through some GCSE questions tonight. So this is where they fall within the intermediate tier. They are on the numeracy and the maths. Okay, so we will fall into both sections, both papers that you do throughout the year. And just to start, if you pause the video and have a go at the questions you can see on the screen, these are all things that were covered in the recordings previously. Okay, so have a go and I'll come back and go over that with you in a second. Okay, so the first question, find 40% of 7,000. That always brings us back down to the 10%. So you're going to do 10% by dividing by 10. So 7,000 divided by 10. And then to get from 10% up to 40%, we multiply then by 4. Okay, this is all non-calculator. You can see on the right-hand side of the screen. So 7,000 divided by 10 is 700. And then multiplying that by 4, then 2,800 should have been your answer for that first question. Question 2, express each of the following as a percentage of the other. Now then we've got to remember that, and I did mention this one in the recordings, these are in different units. One is in weeks and one is in years. So you do have to get them both the same. There are 52 weeks in a year. Okay, so we are going to do this question in weeks. So you start by writing the numbers you have as a fraction, so 13 over the 52, and then you do what you can to try and cancel that fraction down. Now, 13 goes into both of these, so if you divide the numerator and the denominator by 13, you will get 1/4. Now the question said write as a percentage, so do not leave it as a quarter. A quarter as a percent is 25%. And if you couldn't remember that, you could go down the route of getting the denominator to be 100 by timesing this entire fraction by 25. For part B, again, we've got different units. We've got centimetres and metres. So we're going to do this in centimetres. We always go for the smaller unit. So the 4 metres is going to be 400. There's 100 centimetres in a metre. And we're going to start by writing that as a fraction. So 38 over 400. And we're going to get this denominator to be 100 by dividing by 4. And that goes for the numerator as well. That does mean we're going to have a decimal in here. If we're dividing by 4, we're halving and halving again. So it's a 9.5 over 100. But again, we're not leaving it like that. You wouldn't actually get your marks if you leave your decimal in there. But we are going to write it as a percentage, and you can have a decimal as a percentage answer. So 9.5% then as your percentage. And the final question on the screen there, Sally's pay is £25,400 per year. She has a pay increase of 5%. How much is your pay per year after the increase? Okay, so we did do this in both the non-calculator and the calculator sessions, but as you can see, this is a non-calculator question, so we are going to stick to the non-calculator process for this one. So 25,400, we're going to find that 10% by dividing by 10. And then to move from a 10% answer to a 5%, we're going to half that. So we're going to divide by 2 once we have our answer. That will give us then 1,270. Now that is not the answer to the question. That is how much money her pay is increasing by, but the question is how much is now her new pay. So because it's a pay increase, we're going to add that on to the original amount. So we're writing down our methods. So 1,270 is being added on, giving us then an overall answer of 26,670 there. Okay, so we're going to go straight in now to the GCSE questions. And again, you can pause the video and have a go at these before I run through them. We are going to do a calculated question to start. Okay, so we're going to follow the methods that we used within the calculator session. Okay, just get my highlighter. So we have Elvid invests £3,500 for 2 years at 1.5% per annum compound interest. Calculate the value of the investment at the end of the 2 years and give your answer correct to the nearest penny. Okay, that rounding is important. If the question says what it wants it to be, then it does mean there's a mark for that rounding as well. So the calculator process we went through was using something called multipliers. So we're going to start by working out what our multiplier is. Okay, and to find that, we always begin with the 100%. And if it's an increase, we'll add it on. And if it's a decrease, we'll take it away. So because interest is added on, this one is a add-in question. So we're adding on 1.5% to that 100%. That now means we have 101.5%. We write that then as a decimal. So we're going to divide by 100. So 1.015 will be the multiplier that we will use in this question. Okay. So the formula is the amount that we have, 3,500, multiplied by this multiplier we've just calculated, so the 1.015, and then we raise it to the power of however many years we have. So this question is talking about 2 years, so we're going to have a power 2, and then that can go straight into your calculator, and it will work out the answer of how much money is in the account, including the interest that's been added on. But we do need to remember that we are going to round to the nearest penny as the question asks us as well. So it comes out on your calculator to be £3,605.79. And we're going to tell the examiner that we've rounded to 2 decimal places. Okay, so that is your 4 marks for that question. It's quite generous for that question, since you are pretty much just doing one line of workings and then straight into the calculator. On to the next one. So we now have, this is a non-calculator question, so this would be in a unit 1, the first paper that you will sit out of the 2 papers that you do. So it says, when she was in year 7, Yasmin could run 800 metres in 3 minutes and 20 seconds. Okay, so 3 minutes 20 seconds in year 7. 4 years later, when she was in year 11, she could run the 800 metres in 2 minutes and 48 seconds. Find the percentage improvement in her time. Now then, what we don't want to do is to work in minutes and seconds. We want to get everything in as the same unit. So we're going to get this all into seconds. So we're going to set our work out clearly. So we've got 3 minutes, 20 seconds that we're going to convert. Now in every minute, there is 60 seconds. So we have 3 lots of 60 plus the 20 seconds, that's the extra part as well. That now means we have 200 seconds. Okay, so we haven't started the percentage part yet. I'm going to do the conversion again for the other one. So we've now got 2 minutes and 48 seconds. Again, we're going to multiply by 60 because there's 60 seconds in a minute and add on that 48. That gives us 168 seconds. And if you think back to the sessions that I did before, okay, what you had to do for this part of it was to work out the change between what's happened. So from the 200 seconds to the 168, there is a difference, a change of 32 seconds. That gets divided by the original amount. It doesn't matter if the original is bigger or smaller than the other one, it's the original amount that you're starting with. So that 200 was the first number we had. So that 32 is going to be over 200, and just like we did in the starter, we want to get this over 100, so we're going to half both the numerator and the denominator, giving us then 16 over 100, and then the numerator then is your answer as your percentage. Okay, so 16% improvement there for that one. Okay, on to another GCSE question. Again, pause the video, have a little read of this one, try it yourself, and then I'll come back in and go over this one with you. Okay, what is key in this question is this bit that's in italics. In this part of the question, you will be assessed on the quality of your organisation, communication and accuracy of writing. And if you have a look at the marks, there's also extra marks awarded here. Now, as long as you are setting your work out in a logical manner and you're labelling your steps, you will get these marks without really having to think or do anything extra. The examiners are not looking for essays or big paragraphs, it's just the labelling and the way that you set your work out. So it says the charge to stay at a campsite has increased by 5%, okay, each year for the last 2 years. 2 years ago, the charge was £24 per night for a large tent and 3 people. Calculate the current charge per night for the large tent and 3 people, and you must show your workings. So what you want to do here, this is a non-calculator process. So you're not going to be able to do the multiplier method we used on the previous question. You are going to have to set it out as what is the answer at the end of the first year, and then what will the answer be at the end of the second year. So in year 1, we started on £24. That was then increased by 5%. So we need to find 5%, and we've done this already tonight, where we divide by 10 to get 10% and then half that answer. So that comes out to be £1.20. And if you notice now, I'm putting my pound signs on these answers because it is an OCW question, so the units are important. Okay, then because it's an increase, we're going to add that on to what we started with. So £24, add on the £1.20, that is now the increase, giving us £25.20. So that would be the price if I stopped after 1 year. But this question is saying what is the price after 2 years? So actually all we have to do is repeat the process, but this time we don't start with £24. We now start with this £25.20. We're going to divide by 10 and half that, divide by 2 again, and that gives us £1.26. That gets added on to what we started with for this year. Don't go back to the £24, okay, it's the £25.20. And your overall answer then, £26.46. There is nothing more you need to do here. You don't need anything extra to get those OCW marks. It's just setting out your year 1, year 2. You've shown your method, you've put your units on there, everything is clear and logical, and you will automatically get those marks. Okay, on to the next one. So we have the price of software changes each year. The price has increased by 6%, okay, per annum for each of the last 5 years. Before this, and that one is important, before this, the price had decreased by 2% per annum. 7 years ago, the price of softwood was £34 per metres cubed. Calculate the current price of softwood. Okay, so you need to think about this as a time series, really. We're starting 7 years ago. Then if we work back through the question, for the 2 years that come after that, it decreased by 2%. And then the 5 years then running up to where we are now is increased by 6%. Okay, up in the top right, this is a calculator question. So you are now back to your multipliers. So pause the video and see if you can try this question and then come back in and listen to the answer. Okay, so the £34 is the starting price, and then we're going to have a decrease of 2%. Now, if we think of our multipliers, 100% take away 2% is 98%, but we want that as a decimal. So 0.98 would be a 2% decrease. That is for 2 years, so it's squared as a power 2. Now I could, if I wanted to, work that out at the moment and then go on and do the next part, but actually I'll get exactly the same answer if I just do it all in one line. So I'm going to keep going, and the next part of it was to increase by 6%. So that is 100%, add on the 6%, so that's 106, but written as a decimal, 1.06. and that was for 5 years. So the power this time is 5. Okay, now that goes straight into the calculator, and then your answer should have been £43.70. Now the calculator would have come out as obviously you've got to be thinking, you've got these 70, you've got decimal places, you need to have money. Okay, so you need that 0 on the end. Don't forget about the 0 when we are talking about money. And that's 3 marks, that question. So I'm going to run through one more exam question, and then we'll finish off with a little question at the end then. I'll read this one out and then give you the chance to pause. So wood pulp is used to make paper. In 2012, Brazil has produced 14 million tonnes of wood pulp. In each of the next 3 years, Brazil's production of wood pulp is increased by 1.7% of the previous year's production. After 2015, it is expected the production of the wood pulp then will increase by 2% on every year. This happened then. What quantity of wood pulp would you expect Brazil to produce in 2017? Okay, so pause the video. This question is very similar to the last one. Have a little go at it. Okay, so the first thing to note is let's write this 14 million rather than it being in words. We're writing this as digits. Now, million has 6 zeros on there. So 14 million is the 1 and the 4 and then 6 zeros after it. Okay, so that's the number that we're beginning with. That is then going to be increased by 1.7%. So if we think now of those multipliers being used, again, this is a calculator question. Okay, so 1.017 is the multiplier. I mean, 1 doesn't look like a 1 there, but it is a 1. So 1.017, and that was for, I've highlighted it, that was for 3 years. The power is a 3. Then it increased for 2%. So the multiplier for 2% is 1.02, and that was for 2 years. It went from 2015 to 2017. It didn't specifically say for 2 years, but you needed to work out that that was for 2 years. So the power is a 2. Okay, into the calculator, and then you will have your answer. It should have come out as 15,321,145.54, and then this is in tons. Okay, so we're going to get that on there. Lovely. Okay, so we're almost at the end. So I just want to do a little plenary question with you. And this is something that we've related to earlier on, which was percentage change. So the formula you can see in the box there, percentage change is equal to change over the original multiplied by 100. And my question to you is, which has the larger percentage change? So on the left-hand side, we've got the original amount and the new amount. On the right-hand side, it's the same thing again. So can you work them out and compare them? So if you do that now, please. Okay, I'm going to put 2 answers on the screen, should put them up automatically. One of those answers obviously is correct. Okay, so let's just work through that one now for you. Right then, so the first one, you should have been doing the percent, so the amount change, which is 5 over the 67 multiplied by 100. That works out your change there, getting that 7.5%. The next one, 6 was the amount that was changed. The original amount was 56, multiplying by 100, and you had to then say which one was the biggest one. Okay, so what you should have been coming up with was that 10.7% there was the larger one. Okay, so we've come to the end of our sessions now for the live one for this sort of autumn term. There will be more sessions throughout the year, so please feel free to obviously use what's already on the Callum Cymru website, and anything that comes out will be advertised as well. But thank you for sort of taking time to look at these videos, and we hope they've been of use to you. Take care. Bye.